Hi everyone, today I'm working through a word problem that could fairly be asked to any student who's learned how to solve quadratics. So the question says, Bob made a quilt that is 4 meters by 5 meters. He has 10 square meters of fabric to create a border around the quilt. How wide should he make the border to use all the fabric? And we're told that the border must be the same width on all 4 sides. So yeah, let's take a look. So here I've written out the key points from the question. We're told that Bob's got a quilt and here's the dimensions. We want to create a border that takes up 10 meters squared of fabric. And really the question is all about how wide the border should be. And we've got this condition that the border needs to be the same width on all sides. And I think with word problems like this, it's very often the case that drawing up a diagram can be really helpful. I think if you can visualize what's going on with the question, that might help you to work out what the natural next step might be. So I think in terms of drawing up a diagram for this question, it probably makes sense to start with this quilt that we know is 4 meters by 5 meters. So I'll just get my ruler here. Maybe if I use my grid, we could say we're going down 1, 2, 3, 4. Down the grid, and then we'll go across 5. So 1, 2, 3, 4, 5. So that's kind of somewhat to scale our quilt. So if we label these two sides are equal and these are equal, we'll have our 4 by our 5 for our quilt. And the next thing that might be helpful to overlay is the fact we want a border. So maybe I'll do this in a different color, maybe red. I'll just draw a border. Now we don't know how wide the border needs to be, but what we do know is that it needs to be an equal width on all sides. So I'm just going to try and draw a border that adheres to that requirement, that it's the same width on all sides. But because we don't know what that width is, that's actually what we need to work out. It probably makes sense to give that a letter. So in this case, I might call this width here. So the length from the quilt to the outside of the border, we'll call that x. And because we're told that the border must be the same width on all sides, because we've got 1, 2, 3, 4 sides to this border, we know that all of those widths we can call x, because they need to be the same. So we might as well give them all the same letter if they're eventually going to get the same number. And so now the next question is, how can we work out what x should be? Basically that's our question. What is x? Now the one piece of information that we can use that might help us here is that we know the area of this border, the area that I'm shading here, we're told that that needs to be 10 meters squared, because that's how much fabric we've got, and we want to use all of that fabric. So the question is, how can we find this area, this red shaded area, in terms of x? Because if we can do that, we can then set that equal to 10 and see if we can solve for x. And at this point, it's probably helpful to maybe note that visually, if we were to take the area of this outside rectangle, this red rectangle, and subtract the area of this blue rectangle here, then what we would be left with would be simply the border. So that could be the first thing to note. We could note that the area of the border is equal to the area of the red rectangle minus the area of the blue rectangle. So now the question is, can we know what the area of the red and blue rectangles are, particularly in terms of x? And so maybe it's worth annotating onto our diagram what the dimensions of this outside red rectangle are. Because we know the dimensions of the blue rectangle, we were told it's 4 by 5, that's the quilt. But the border, what we can note is that in terms of, first of all, the height of this border, We can work that out in terms of x because we know we've got 4, a height of 4 here from the quilt, and then we've got an extra x at the top and an extra x at the bottom. So essentially this total height would be 4 plus x, or in other words we could write that as 4 plus 2x. So that's the height of this red rectangle. And the width, we can use a similar approach. The width of this red rectangle, we can say is 5 with x on one side and x on the other. So that gets us 5 plus 2x. So now that we've got those dimensions, we can work out the area of that red rectangle because it's simply the height times the width. And the same with the blue rectangle, it's the height times the width. So this area of the border we can write as the area of the red rectangle, which would be 4 plus 2x times 5 plus 2x, minus the area of the blue rectangle, which we could write as simply 4 times 5. So now we just need to expand these brackets. So we'll have 4 times 5 plus 4 times 2x plus 2x times 5 plus 2x times 2x minus 4 times 5. And whilst we know 4 times 5 is, hopefully you know, is 20, we don't actually even need to do that because we can see that 1 4 times 5 will cancel with the other, so they'll disappear. So in terms of simplifying this, we'll get 4 times 2 is 8x, plus 2 times 5 would be plus 10x, plus 2x times 2x would be, the 2 times 2 is 4, and the x times x would be x squared. And so we've got just 4 of our x squared, and then 10 plus 8 would be 18 of our x. So that's the area of the border that we're concerned with. So therefore what we can say is we need that area, that 4x squared plus 18x, to be equal to our 10, to represent our 10 meters squared of fabric that we've got. And so really we need to ask what value of x will give us this, and it'll be helpful to bring the 10 over so that we've got a 0 on the right hand side. So let's do that. So we'll have 4x squared plus 18x minus 10 is equal to 0, because now that we've got a 0 on the right hand side, hopefully you can see that over here on the left we've got a quadratic in that classic form, something x squared plus something x plus a constant, or minus a constant in this case, is equal to 0. So now we need to solve for x. And there's a few ways you can do that. I mean, you could simply use trial and error if you haven't learned any techniques, and hopefully it wouldn't take you too long to maybe find a value of x where this is true. But if you've learned techniques like completing the square or the quadratic formula, then you don't need to worry about trial and error, which is a bit clunky, because we can just go straight to x. And I think if you have learned the quadratic formula, it's probably, I'd say, the simplest way to go, because you kind of just throw your coefficients into the formula and you know you're going to get the answer. Whereas completing the square, you'll still get the answer, it just takes a bit more thought, and depending on how long ago you learnt it, maybe you're a bit rusty on completing the square. So I'm going to go with the quadratic formula. So what we can say is that x will be, I'll just write it in generic terms, negative b plus or minus root b squared minus 4ac all divided by 2a. And in our case, that's where a for us is 4, the coefficient of x squared. B would be equal to 18, the coefficient of x. And then c would be negative 10. So we've got to make sure we catch that negative as well. So if we throw those values in, we'll get x being equal to negative 18 plus or minus the square root of 18 squared minus 4 times 4 times -10. And that's all going to be divided by 2 times 4. Alright, and if we just evaluate what's under this square root sign, so I'll get out my calculator, and we'll go 18 squared minus 4 times -10, we get 484. So it's the square root of 484 over 2 times 4 is 8. And at this point I might turn over just so that we can carry on the next page. So therefore we can say that x will be equal to -18 plus or minus, and let's have a look at the square root of 484. The square root of 484 is 22, which is nice and clean, and it was all divided by 8. So now we could plug this into our calculator and get our two values of x. So if I start with minus 18 plus 22 divided by 8, that gets us 0.5. Or we've got this other value of x, which would also solve our quadratic, which would be minus 18 minus 22 divided by 8, which would be -5. So at this point we have to make a choice. Which of these values of x is the value that we should use for the width of our border? And if we come back to our question, because we've got a quilt and we want to put a border around the quilt, so in effect x makes the whole quilt bigger, we know we need a positive value of x, because conceptually a negative value of x would actually be taking away from the quilt. You'd be subtracting fabric from the quilt, whereas we want to be adding it. So for that reason, whilst we have two solutions to our quadratic, we need to kind of understand the context of the problem to know that actually for us, x is equal to 0.5 is what we want. So therefore we can conclude that the border should be 0.5 meters wide. And that's how you can tackle that question. So hopefully that all made sense. I think when you're given a word problem, some students may find them a little bit daunting, because whilst you might be used to just seeing numbers and sometimes maybe even letters and variables thrown around, you may not be as comfortable with having to convert the words into the mathematics. So my advice would always be, where you can, draw a diagram, because hopefully the diagram will give you a bit of a hint as to what the way to go would be. And in our case, once we drew this diagram, we could see that we've got one big rectangle minus a small rectangle, and from there everything fell out quite nicely. So there you have it with that question, and tick boom.
I understood the assignment. I understood the assignment.